All right, now we need to make a residual plot. Okay, a residual plot, let's go back to our favorite tool here, our calculator, and let's look at making a residual plot. So let's clear our key history here. Now we already have the scatter plot made. We already have the regression line. So a residual is what we observe, or what the actual y value was, minus what's the y value when we make our prediction using our model, our LSRL, or our least square regression line. So this is a little more involved, the steps in constructing this residual plot, and probably we won't be asked on the AP test to actually make a residual plot, but we'll certainly be asked to interpret one. What does this plot tell us? Okay, so before we get into how to read a residual plot, let's look at how to make one. So I'm going to go back into my lists by going into Stat, Edit. Okay. Now I want list 3. So I'm going to go over here to list 3, and I'm going to put in a formula into list 3. What I want is the actual y values. Oh, my actual y values, those are in list 2. So L2. Yep, L2 minus my predicted values. And as we saw on the previous page, how do we make a prediction? We plug the x values in to the least square regression line, which we have conveniently stored in y1. So where's y at again? It's in vars, y vars, function, y1. And then we wanted to plug in x. We're going to have the calculator do all of these for us. I don't remember how many data points there were here, 18 or something like that, data points, 16, 18 points. I would have to do those calculations 16, 18 times. No way. The calculator is going to do it for us. Remember that the calculator is the muscle, we're the brain. So if we know how to manipulate the lists, we can have the calculator do all the work for us. So L2, the observed or the actual y values, minus the predictions. Well, let's plug in all the x values. So instead of me typing in all of the x values in list 1, I'm going to tell the calculator to do it all for me at once. So L2 minus y1 parentheses L1. This is going to give us a list of the residuals. So I hit enter and it calculates them all for me. Okay. So now I have a list of all the residuals. Remember, a residual is just the difference between what we observe and what we predict. Now that I have the residuals, I can try to make a residual plot. So I'm going to go into my y equals, and I don't want it to graph the line. Instead, so to make the line go away, you deselect the equal sign. Put the cursor on the equal sign, hit enter, and you'll notice now that y1 is still there, but the calculator knows not to show it to us. Okay, and I'm going to make y2 0, because what I'm trying to see is how much did we over predict or under predict. So if we predicted perfectly, then the residual would be 0. If we over predicted, then it would be negative. If we under predicted, then it would be a positive value. So we're going to turn y2 equal to 0. And then we're going to make a scatter plot. So I have my plot 1 turned on, but I don't want L1 and L2. I want my x values versus my residuals. So I wanted to do L1 and L3. So again, I want the horizontal line y equals 0 with the scatter plot of L1, my x values, and L3, my residuals. I'm going to hit graph. Oh man, I don't see much. That's all right. Remember, we have this special thing that's going to help us in this class with Zoom Stat. There is my residual plot. So what? Why? Well, what is this telling me? It's telling me the vertical distance each one of these points is away from the line. It's telling me how much did I under predict or over predict. And really all a residual plot's doing in a lot of ways is taking this original graph and spinning it. So if you were to take this least square regression line and draw it horizontally, now you notice that on the residual plot, the y values have changed. On the original scatter plot, the y values was the price of the truck. But on the residual plot, the y values are now the residuals, or how much did we over or under predict. But basically all it's doing is taking this original graph and turning it horizontal so that the LSRL, the y hat, the prediction line, is now a horizontal line. And we're looking at these vertical distances x or y is away from the line. So on the right, on our residual plot here, we look at the residual plot and see, is there a clear curved pattern among these dots? Or is there random scatter? So on a residual plot, what we're trying to look for is this. If there is no pattern, good. No pattern means the data is linear. We have random scatter. So no pattern tells us linear. That's a good thing. On the residual plot, it's going to tell us the form. Remember, we need form, direction, strength. Form and direction come from R. I'm sorry. Direction and strength come from R. Form comes from the residual plot. So all of this process to make the residual plot is for one purpose. What is the form? Is this data linear? Remember, least square regression line, it only describes linear data. So we need to make sure that this data is linear. And the residual plot is what's going to tell us if it's a linear or not. No pattern means linear. Pattern, bad. If we see a pattern, that's bad news. Pattern means non-linear. And if you look hard enough, you could probably find a pattern in any scatter plot. What we mean by pattern is there a clear curved pattern? For example, if the residual plot looks something like this, we would say, oh yeah, you can see the black lines I just drew on there. There's clearly a curved pattern. Therefore, this form is not linear and my model is useless for making predictions. Okay. Now, the residual plot that we have here has random scatter. So there is no curve pattern. Therefore, this model is appropriate. If there is a curve pattern, we say, oh no, this is not an appropriate model. We do not feel comfortable using this model to make predictions. However, this residual plot does not have a clear curved pattern. Therefore, yeah, we're in good shape. And we know that this model that we've constructed is useful in making predictions. So form, direction, strength, unusual. Okay. Form, we just talked about it. Where do we get form? The residual plot gives us form. Where do we get direction and strength? R. Negative, direction. Positive, direction. And how close are we to 1 or -1 is the strength. Unusual, we get from looking at the scatter plot. Is there any points that look weird? Okay, anything that doesn't seem to fit the overall pattern. So once we've learned form, direction, strength, and how to look for unusual, we know how to describe the distribution, which is how we started off this year, was describing distributions. When we look at one variable again, we talk about shape, center, spread, unusual. Shape, center, spread, unusual. Now, when we're looking at two variables, like we are right now in regression, we talk form, direction, strength, unusual. Form, direction, strength, anything unusual.